First of all, we need to know what's an airbag. So according to the definition of an airbag is principally made of a thin nylon fabric, which is folded into the steering wheel or dashboard, or more recently the seat or door, because the airbag is going to inflate or it's going to expand depending on where the crash is going to happen. So that's why the airbag could be located in different points or in different parts of the car. Now, under what conditions an airbag is activated? So according to our investigation, an airbag is activated when a sensor measures an acceleration bigger than 3g. This happens because when the car crashes, the acceleration increases. So when this acceleration is bigger than 3g, this electrical sensor, gives an electrical sign that makes that an electrical contact change from its position. In other words, this electrical contact, when the acceleration is lower than 3g, this electrical contact is open, but when this acceleration is bigger than 3g, it changes its position, so this electrical contact closes. And all this procedure, happens in a time of between 30 or 40 milliseconds. Now, how does an airbag is inflated? So until this point we know that when this electrical contact gets closed, the airbag is inflated. But what happens inside the airbag? Well, inside the airbag there are two chemicals that are thermodynamically stable but kinetically unstable, which means that when there exists a great acceleration, these both chemicals are going to react between them. And these both chemicals that are inside the airbag are the sodium acid and potassium nitrate. So when they react between them, they are going to produce nitrogen gas. And this nitrogen gas is going to be responsible to inflate the airbag. So when the person hits the airbag is going to be full of nitrogen gas. After the crash from the car, then all the nitrogen gas is going to get out of the airbag through some little holes that will be inside the airbag.
The reaction breakdown and state of each component. We start with sodium acid in solid form, which decomposes into nitrogen gas in gas form and solid sodium in solid form. The components of this reaction are harmful to health, especially sodium acid, which is very toxic, and acid when decomposes generates solid sodium, which is harmful to health. That is why there are two other compounds that help prevent the harmful effects of sodium after a reaction. The first one is potassium nitrate in solid form, which reacts with sodium to form more nitrogen gas, which leads us with sodium oxide in solid form and potassium oxide in solid form. And the other one is silicon dioxide in solid form that reacts with potassium oxide and sodium oxide to form a solid silicate glass that is harmless, and with this last reaction it is possible to eliminate the harmful effects on health. The three reactions have a very hierarchical order. As you can see, the reactants of each step are dependent on the compounds resulting from previous steps. We start with the compounds, which is the sodium acid in solid form, the potassium nitrate in solid form, and the silicon dioxide in solid form, which leads us with nitrogen gas in gas form and silicate glass in solid form. As you can see, each side of the reaction is balanced. Thank you.
So the chemical reaction to inflate an airbag can be divided into three chemical equations. The first one that starts with sodium acid will liberate metacyclic sodium and nitrogen at the moment in an ignition process. Nitrogen is a very good gas. So to inflate an airbag, that is the reason we use it, because it is not a toxic gas and expands a very fast way. But liberates metasolic sodium, that is a toxic molecule for the human body that causes hurts or so. To contrast this disadvantage of using sodium acid, we will use potassium nitrate and we add to the metacyclic sodium, and we will create potassium oxide and sodium oxide. These are also toxic molecules, but in this way it is easier to eliminate the toxic components or to make it not harmful for the driver. We add silicon dioxide and to the sodium oxide and to the potassium oxide, and we will get potassium silicate and sodium silicate. That it is also known as silicate glass, and silicate glass is not a toxic molecule for the human body. So that is the chemical reaction divided into three equations that is carried out when it is inflate an airbag.
Hi. To calculate the mass of reactant needed to supply the airbag, we first need to write the information and formulas that we have. According to an article written by Ahmad, an airbag has a volume of 60 liters. Likewise, to solve this problem, we are going to use the ideal gas formula, but clearing the expression and to calculate the number of moles in nitrogen. We will assume that the pressure is the standard pressure, that is 1 atmosphere. We are also going to consider a temperature at 298 Kelvin. We use the ideal gas formula to obtain the number of moles, and it gives us a result that the nitrogen in this reaction has a total of 2.45 moles. Next, we apply a rule of 3 to get the number of moles in the sodium acid, which gives us a result of 1.53 moles. The last step is to convert moles to grams, clearing the formula from N, which is the number of moles multiplied by the molar mass. Doing the operation gives us that the amount of mass of the reactant to generate a volume of 60 liters is 99.53 grams. Now, to calculate the enthalpy, entropy, and gas free energy of the reaction, we will use the values of the substance in the tables. For the first reaction, which is balanced, we will begin by calculating the enthalpy. For this, we only use the enthalpy value of sodium acid because sodium and nitrogen have zero entropy. We use the formula to calculate enthalpy and obtain a value of minus 43,400 joules, which represents an exothermic reaction. To calculate the entropy, we use the entropy values of each substance. We replace them in the equation, and applying the formula, we obtain that the entropy of the reaction is 486.6. That means that the entropy increases the disorder. Finally, to calculate the Gibbs free energy, we apply the formula based on the values obtained, and it gives us that the energy is 188,406.8. That means that the reaction is spontaneous. To calculate the temperature of the reaction, the Gibbs energy is equal to 0 and temperature is cleared from the equation, giving us a temperature of minus 89.19 Kelvin.
Now, it is important to talk about the precautions to be taken with the reagents and the products that are present in the airbag. There are some general precautions that we have to take when we use or when we are near to reagents or products involving the airbag. Some of the general precautions that we need to take is, first of all, use goggles to protect our eyes because all of the reagents and products can damage our vision. Also, we have to use safety equipments such as ventilation hood, gloves, mask, boots, etc. because we have to make sure that any of the chemical components touch our skin because all of the reagents and products are really harmful for our skin. Some of them can even burn part of our skin. Also, all of the chemicals have to be stored in ventilated, dry and cool places so they can maintain their chemical properties and they can keep being useful. The same way, all the chemical components have to be far away from food or water because if any particle of the chemical components that the airbag contains, it can intoxicate the human body. But also there are some special precautions that we have to have with some elements. We have to keep away from heat or flammable products such as the sodium acid because at high temperatures it doesn't stay stable, or sodium oxide which is not combustible but facilitates the combustion of other substances. Also for potassium acid we have to keep it away from water because as it is a strong base it reacts violently with water. Also we need to keep the nitrogen stored in areas where the temperature is under 50 Celsius degree, and for sodium and silicon dioxide we have to keep them in places between 15 and 25 Celsius degree.
Well, the damage that can be caused to the environment with the chemical residues of airbags in a car. Well, some of them is the nitrogen, and in the case of the nitrogen, if it is a big quantity of nitrogen in the atmosphere, it will contaminate the water bodies. This will affect the agriculture, so this is a big problem to produce food of quality. So this is a big problem. But as this chemical reaction liberates a small quantity of nitrogen, we can neglect this possibility, but it's something that we need to take into account. In the other hand, we have sodium silicate that, thanks to his high level of pH, is toxic for the environment. So it will be toxic for the plants and can affect the life of the animals. But instead of the potassium silicate that is not harmful for the environment because it's mainly used for pesticides.
Appropriate and safe procedure of handling airbag waste. Deployed airbags are considered to be ordinary solid waste. Airbags are encouraged to direct them measure for recycling. Undeployed waste airbags must be managed as hazardous waste and should be sent for recycling, not reuse or disposal. On one hand, it is possible to disassemble the airbag out of cars out of use that it integrates a process of disarmament and disintegration. The airbag assembly must be removed by the personnel duly trained for the process of disarmament and disassembly. And in the other hand, we have the handling and destruction of the airbag, in which as the first measure the explosion of the same must be guaranteed, since the bag works with a high amount of chemicals that that need any reaction of energy can generate violent explosion. It is most guaranteed that the explosion process is carried out in a remote area with elements that covers and reduces the waste generated by the explosion. As we mentioned before, sodium acids produces many gases which generates danger in confined spaces. This can be very destructive for the environment if it is left in outdoor spaces and it is soaked into powder. It can have a risk of harmful inhalation because it quickly reaches a harmful concentration of particles in the air. On the other hand, the nylon from which the bags are made is not biodegradable. It can take more than 500 years to be absorbed by the nature, and some of the chemicals it leaves in its wake are contaminants.
Airbags are a mechanism that save people's lives every year, where they use concepts of chemistry and properties of substance with the objective that the airbag inflates with the highest possible speed, without injuring the driver. Likewise, we must be responsible when we discarding a car or changing an airbag, because the compounds inside it contaminate the environment and need a specific treatment.